Cool. FYI, the cluster named cluster 1 and the worker nodes have similar cluster 1 automatically provisioned using the EKS CTL tool. So if anyone cares, they can play with that.
Web link.
This happens in the background, performed by the EC2 instance, launch instances. We don't need access to that, so we can ignore it. We're in the EKS service and the console. Got cluster 1. Click on cluster 1. We're going to review the cluster information. So Kubernetes version is set during the lab launch time. It may be lower version than the latest, but it doesn't matter. 128 is what is set. Now go to EC2. Click on instances, and then we should see the worker nodes listed as well, which we've already spoken about. So yeah, this took 20 minutes to load up, so we can have a first check of this lab, which is just to check if the cluster is active. So, which it is, thank God. Right, we can actually do something. So let's go next step. Installing Kubernetes management tools and utilities. So in preparation to manage the Kubernetes cluster, we're going to install several Kubernetes management related tools. This lab step, we're going to install kubectl, command line utility used for communicating with the cluster and the API server, and AWS CLI, which is used to retrieve the EKS cluster connection details. It'll be written to the kube config file. So we want to go to here, I guess. Alright, and let's paste that. So we're going to download kubectl. Privileges on .kubectl. That was supposed to spell change mark properly. And then sudo cp kubectl. Copy that to user local in and export path equals user local path. Cool. Now we can test that the kubectl version client equals true. Do like that. 1 equals, that's fine. So we've got client version and custom version. Right, now I download the AWS CLI. That's it. AWS. God, how much stuff is in here. Finally done. Right, sudo AWS install. You can now run AWS version. Okay, right, so we've got the CLI installed. Right, we're going to use the CLI to retrieve the EKS cluster name, store it in a variable, so let's copy that. And then echo EKS cluster name cluster 1. Alright, now use the AWS utility to query and retrieve your EKS cluster connection details, saving them to the kube config file. AWS EKS update kube config. Name is EKS cluster name. Region US West 2. Added a new context arm to home user kube config. There we go. View the EKS cluster connection detail. This confirms that the EKS authentication credentials required to authenticate have been correctly copied to the kube config. Enter the following command: cat kube config. Okay, so we've got cert authority, user on, then we do kube. Use kubectl utility to get the cluster worker node. So we want kubectl get nodes. So we've got those two nodes that we made. And then finally, just use the kubectl utility to describe in more detail the worker node. So get nodes, we want described nodes. All the detail. That was it. So this check if kubectl is installed on the cloud instance. It's passed. Right, now we're going to do an architecture review. The cloud native application is architected using containers, presented with a web application. Front end provides the end user with the ability to vote on 6 programming languages. So the architecture of the cloud native app will expose you to configuring, deploying and managing the following resources: namespaces, secrets, deployment service, stateful set, persistent volume claim. Application architecture. The EKS Cloud Native Application architecture consists of 3 components: a front end, an API, and a database running MongoDB. Following sequence diagram shows the messaging is used by the application when the app first loads. Key points of the diagram are to load the application. Programming language component makes an AJAX call to language's name API endpoint. This retrieves the details of the programming language keyed onto the name. API in turn connects to the backend, forms a database find filtered on the programming name, returns a document that contains all the details about that language. A response containing the language then comes back to the browser renders it. Following a sequence diagram, the messaging as used within the application is an end user clicks on the +1 button. Clicking on +1 creates an AJAX call made to the language's name vote endpoint. This then connects to the backend and performs an update 1 filtered on the programming language and increments the vote field. Okay. Front end is developed in React. For the purpose of the lab, the front end has been compiled into a package and is into an existing image. Front end is deployed using the following Kubernetes resources. So there is a deployment resource which launches 2 pods containing the front end configured to listen on port 8080. Service is a type of load balancer. It provides the stable IP to sit in front of the 2 pods containing the front end. Service, once deployed into EKS, will result in a public-facing ELB, Elastic Load Balancer, being created. Externally, the service listens on port 80 and it will forward traffic internally to 8080. I've got the code there if anyone wants to look. So there's the repo.
Web link.
API is developed in Go. For the purpose of the lab, the API has already been compiled and delivered into an existing container image. This one has a deployment of 2 pods containing the API on 8080. Service of a load balancer, similar to the other one, forwards 80 onto 8080. There's an API endpoint for languages, languages/name, name/vote, OK, and to post and delete those languages. That's got the code as well, so that's the back end.
Web link.
Then there's a Mongo NoSQL database used for the persistence layer. MongoDB provides the schemaless NoSQL approach to storing data. Right, so this will be deployed using the Kubernetes resources stateful set, which will deploy 3 pods containing the MongoDB service configured to listen on port 27017. It's headless. It will sit in front of stateful set, creating a stable network name for each pod, as well as the stateful set as a whole. We have a persistence volume, one for each individual pod and stateful set. MongoDB will configure to persist all data into a directory mounted in the persistent volume. And there's a persistent volume times 3, one for each PV, binding a PV to a pod within the stateful set. Okay. So how are we going to do this? We've got we're going to recreate namespace, which will be used to contain all the cluster resources. Let's copy that. So we need to create the namespace. Configure the namespace to be the default. So we need to run that. And then deploy the MongoDB replica set. We're gonna kubectl get storage class. Create a new Mongo stateful set named Mongo. Let's use this. Note that the auth flag hasn't been enabled on the database. This is done so it's quicker and easier. Examine the MongoDB pods ordered sequence launch. So we're going to run kubectl get pods and run a watch on the pods. We have to wait for all 3 pods, Mongo 0, 1 and 2, they have to reach and recording the running status. So we've got 0's ready, 1's ready, just need 2 to be ready and we're done. There we go. Right, cool. So Control C ends the watch. Do cube, CTL, get pods, dash L, roll equals DB. Okay, so there's the three pods with database role all running. Cube, CTL, get pod. We want persistence volume and persistence volume claim. So that gives us the pods, the persistence volume, and the claims for those three. Alright, and now we need to create a headless service for Mongo. In the terminal we run this command, so yes, that's the service created. That's it. Now we can examine the newly created headless service by doing kube ctl get svc. Start running that. Now we want to examine the DNS records produced by the headless service deployment. Create a temporary network utils pod, enter into the bash session with it. In the terminal, we need to run the following: kubectl run rm rf utils IT image QMA network multi-tool bash. Okay, we've got a bash. Alright, create a temporary utils pod in the current namespace. This will ensure that the NS lookup queries to be performed next are done so in the same space within the MongoDB deployment. Within the utils pod, execute the following queries. It's actually giving me a full command, so we're just going to run that. So this will confirm that the DNS records have been created successfully and can be resolved within the cluster. One pod exists behind the headless service, and we can exit. So exit. Confirm that the Mongo shell can now be resolved to the 3 Mongo headless services assigned DNS names. In the terminal, run the following command. So it's just going to connect to each instance. Right, before proceeding to the next step, make sure that the previous command ran successfully, which did. On pod 0, initialize the MongoDB replica set. In the terminal, run the following. This is lots of copy paste, not a lot of other shite. Wait until this command completes successfully. This will take 10 to 15 seconds.
42 raiders from B7H30 have joined.
I've raided myself apparently because I was still lurking in your chat.
It's just a folder.
Theo says.
Riff-raff inbound.
Smile, smile.
That's a good trick. I didn't know that.
How was the stream?
Lol.
We're like halfway through a Kubernetes cluster build, so this is fun. Most of it's all just copy this command.
There is a lot I don't, Tino.
Copy a command, paste it, watch it complete, and then copy the next command and paste it and watch it complete. But yeah, so so that's finished. Confirm that the MongoDB replica set has been correctly established. In the terminal, run this command. Yeah, so it has. Load the initial voting app data into the database. We need to put some data in there.
Cool. Kubernetes is on my list.
That inserted some dummy records, and then confirm that the voting app data has been loaded correctly. You have to run the following. So this kubectl exec mongo 0, and then just language is fine pretty, so it's just pretty printing the language output. Cool, now we can deploy the API. So this will involve a secret, a deployment, and a service. We have to create the secret to store the database connection detail. This is done for demonstration purposes only. Security auth hasn't actually been enabled. So generate username, password. Love this song. Alright, so just paste that in. If you know the game this is from, you're getting some extra kudos. If you don't know, it's going to say the name in a minute. Actually, it might not. It does on the N64 when you turn it on. Alright, so that's made some dummy creds.
A Zelda game?
No, it's a beat 'em up. No one got it? It's Killer Instinct. Such a good game.
Street Fighter.
Similar, but like way more gory.
Oh, noise.
Right, so we're going to create the secret resource to hold the credentials. So this command's doing a kubectl apply. It's applying a secret or a kind of secret, and then the data is there. Okay. Lots of copy paste stuff that you just would have to prep beforehand, I guess. Right, then create the API deployment resource. So you need to build that. Thank you for the follow. And then finally create the service resource of load balancer. And this also deploys it. Alright, and then last step, confirm the API setup within the cluster, examine the rollout of the API deployment, examine the pods and confirm that they're up and running, and examine the API service detail. Another copy-paste job. So, kubectl rollout status deployment API, get pods roll API, get service API, so this should. So deployment API was successfully rolled out. They're both running. API load balancer is running. Brilliant. Cool. Now we need to test and confirm the root URL. The OK endpoint can be called successfully. Another copy paste job. Okay. That just basically runs the curl command, but from within the Kubernetes cluster. DNS propagation can take 2 to 5 minutes. Please be patient while the propagation proceeds. It will eventually complete. Test and confirm that the API root URL languages and languages name endpoints can be called successfully. So this is testing the other endpoints. Okay. Alright, so that looks like it worked. So now we can deploy the front end. We're going to retrieve the fully qualified domain name of the API load balancer, store it within API public fully qualified domain name variable. That value will be stored and injected into the front end React's API host port environment variable. And this is another copy paste. This is all stuff you'd have to prep, isn't it? That's done. Create the deployment resource. And create a new service resource of load balancer for this. So another load balancer. This one's for the front end. Confirm the front end setup with the cluster. Examine the rollout. So same as the database one. Front end was deployed. It's on the both nodes. It's running and can be reached. Confirm that the front end
says, now that song is a Zelda song.
Yeah, this one's Zelda. Which Zelda though? And which song?
Oops. Translated from Estonian.
Close. So this command is going to confirm that the front end is ready to receive HTTP traffic, which it is.
Oh yeah, it was actually from Majora's Mask.
Yeah, that's the one. Right, DNS propagation can take 2 to 5 minutes. It's already done, so we don't need to bother. We can generate the front end URL for browsing. So this will give us a address. Alright, using my local workstation browser, we can view the URL after voting. The application is after the voting app has loaded. Vote by clicking on several +1 buttons. This will generate some AJAX traffic, which will be sent to the API via the API's assigned ELB. It's just +1, +1, +1, +1, +1. Query the database to directly observe the updated vote data in the terminal. Execute the following. So this time we're running kubectl exec mongo 0, and we're running, oh, it's another pretty print, so that's basically the same as what we did earlier, just with more information. Votes 1, 1, 1, 1. Like 1, 1, 1. Should work votes 2 now. Yeah. Bonus step, use the developer tool within the browser to examine the AJAX calls are being generated by the voting. Okay. That's all we had to do. So, all we had to do, I say, running shitloads of bloody commands that were given to us. So yeah, was the Cloud Native app deployed correctly in EKS? Let's have a look. It was. Here we go, that was it.